All right, folks, here we go. This will be example number 7 for higher degree equations. This will be the last example that we'll have time to work together, and this should prepare you to do that homework assignment number 12. So, again, this is a higher degree equation because of the 5th power, the 3rd power. Anything higher than 2 is a higher degree equation for our purposes. So here we go. We don't have any fractions to clear. Distribute. Yes. Over here on the right-hand side of this equation, there would be some distributing to perform. So we'll multiply that expression into the parentheses. And therefore this would be what? Negative 14x to the 4th power. Negative times a positive, negative 20x to the 3rd. All right, so we have that. Now you'll notice that there are multiple terms that have the variable x. So here we go again. Is the variable on one term? No! Let's get everything on one side and make it equal 0. Now, we can agree to disagree here. Reasonable minds can disagree. That's assuming I'm a reasonable mind. But to me, the fastest way to get it in standard form would be to move this one term over to that side, and that's what I'm going to choose to do. So, if we were to subtract this negative 2x to the 5th power over to the other side, so the point to keep in mind is it really doesn't matter what side we get the 0 on. All right? It can be on the left, it can be on the right. The main point is to get every term on one side. What would happen if I moved all these over there? Well, good question. It would still work, all right? So potato, potato, I don't care, all right? But anyway, time is wasting. I've decided to get the 0 on the left-hand side of this equation, all right? So I'll transfer this equation up here again, and I'm sure it's exciting to watch me do that, but anyway, that's the way it works. So, this now basically becomes an exercise in factoring. Now remember, there's formulas to solve this. Actually, for 5th power, there's not. But anyway, the idea here would be that we would need to factor this thing. So we look at factoring, and again, my links aren't working as well as I would like, so I apologize for that. But in the process of factoring, I hope you would realize that because that first term is negative, all right, because that first term is negative, Mr. Salisbury's steak, I have a list of names that I'm using, all right, but Mr. Salisbury's steak would suggest that you factor out negative. Get your negative out of here, all right, and you can divide a 2 out, a factor of a 2, and you can also factor out x to the 3rd. All right, so I would advocate factoring out negative 2x cubed. Again, get your negative out of here. So that would leave x squared in the parentheses. This times this is this. This is factoring. This is assignment 5. Go back and review it if you need to. It was on our first test before spring break. That would become 7x. And then this would become, let's see, that's plus, because a negative times a positive negative, plus 10. All right? Now, at this point, we're out of the woods because we could set each one of these equal to 0 and solve them. But look, factor as much as you can. And I'm pretty sure that this trinomial here, this baby trinomial, would be the child of these two binomial parents that fell in love and got married and foiled. All right, this makes this, as we discussed on assignment 5. So we do indeed have 3 factors now, and it equals 0. So we employ the 0 product principle, whereby we set each individual factor equal to 0 and solve them individually. All right, now look, what would x have to be for all of that to equal 0? 0. I skipped some steps. Sorry. I hate doing that, but you know, I only have so much time to get these questions up here. So let's see, x would equal negative 5, and on this one, x would equal negative 2. Recall you'd have to subtract the 2 over to the other side. So we have these 3 real solutions, and so let's report the answer here somewhere. 0, negative 5, and negative 2, and again, please, 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 I implore you that when you do homework, and you've been doing a great job all semester of circling your answers so I can find it on your paper. And that's especially important when there's multiple values of x like this. Let's put them all together in one place. That's called a solution set. It's good math, and it just makes the paper grader happy. All right? So anyway, that's the end of higher degree equations. That's as far as we're going to be able to go with this. I guess as we go out of here, let me see if I can pull this off. I was going to go ahead and leave us with some music here from our favorite mathemusician Algebra, who did a cover tune by Aeromath of Sweet Equation. So enjoy. Oh, my ears are bleeding.
Looking for answers to family affairs. Trifactory or complete this square. If you need solutions and you need them quick, there's a formula there for applying that in.
Obviously, I need new speakers here, all right? But anyway, that should be the end of higher degree equations, and you can find that video in its entirety on YouTube if you just search Algebra Sweet Equation, among many other videos that'll make your ears bleed. And by the way, I'm aware that my singing is terrible, okay? All right, thanks.